Welcome to Bot Thoughts by Soft. I'm Alex, and today we're tackling one of the biggest debates in the developer world right now. TypeScript and Rust are both surging. TypeScript just became the #1 language on GitHub, overtaking Python. Meanwhile, Rust has been the most loved language in developer surveys for 8 years running, and companies are rewriting critical infrastructure in it. So if you're a developer in 2026, where should you invest your learning time? Should you go deep on TypeScript? Should you bet on Rust? Can you do both? Sam, let's set the stage. How did we get here?
The story starts around 2012 when Microsoft released TypeScript as a typed superset of JavaScript. At the time, most people dismissed it. JavaScript was already everywhere and CoffeeScript was the trendy alternative. But TypeScript did something brilliant. It didn't try to replace JavaScript. It added a type system on top of it and it compiled down to plain JavaScript. So you could adopt it gradually, file by file. Fast forward to 2026 and TypeScript is everywhere. React, Angular, Vue, Next. JS, Deno, Bun, Node, every major framework either uses TypeScript by default or has first-class support. It's in the browser, on the server, in mobile apps, in infrastructure tooling. When GitHub's data shows TypeScript overtaking Python, that's not a fluke. It's the result of a decade of steady adoption across the entire stack.
Okay, so TypeScript ate the JavaScript world, but Rust's rise is a completely different story. What's driving that?
Rust is solving a fundamentally different problem. For decades, systems programming meant choosing between C and C++. Both give you incredible performance and low-level control, but they're memory safety nightmares. Buffer overflows, use-after-free bugs, data races. Microsoft reported that 70% of their security vulnerabilities were memory safety issues. Google found similar numbers in Chromium. The industry spent billions on bugs that a better language could prevent. Rust eliminates entire categories of these bugs at compile time through its ownership system. No garbage collector, no runtime overhead, but also no memory corruption. That's revolutionary. And the timing was perfect. Cloud infrastructure costs are exploding, so companies care about performance again. AI inference needs to be fast and efficient. WebAssembly needs a systems language that compiles to it well. Embedded systems and IoT need memory safety without garbage collection. Rust hits all of these sweet spots.
Here's what I find interesting, though. These two languages don't really compete head-to-head, do they? If I'm building a web app, I'm probably not choosing between TypeScript and Rust.
That's exactly right, and this is the most important point in the whole conversation. TypeScript and Rust occupy different niches with a small but growing overlap. TypeScript dominates application development. Web frontends, APIs, serverless functions, full-stack frameworks like Next, JS, and SvelteKit, mobile with React Native. If you're building something that users interact with, TypeScript is probably your best bet. Rust dominates systems and infrastructure. Operating system components, database engines, blockchain nodes, game engines, embedded firmware, CLI tools. If you're building something that other software runs on top of, Rust is the natural choice. The overlap is in the middle, backend services that need high performance, data processing pipelines, developer tools, WebAssembly modules. This is where things get interesting because both languages can do the job, but with very different trade-offs.
Let's dig into those trade-offs. If I'm a developer evaluating both, what does the day-to-day experience feel like?
TypeScript has a much gentler learning curve. If you know JavaScript, you can start writing TypeScript in a day and get productive in a week. The type system is gradual. You can use any to opt out when you're learning. The ecosystem is massive. NPM has over 2 million packages. The feedback loop is fast because there's no compilation step in the traditional sense. You write code, save, and your dev server hot reloads in milliseconds. Rust is a different beast entirely. The learning curve is steep. The borrow checker will fight you for weeks before it clicks. There's no escape hatch like any in TypeScript. The compiler is strict and it won't let you cut corners. A survey by the Rust Foundation found that the average developer takes 3 to 6 months to feel productive in Rust. But here's the flip side. Once you get past that learning curve, Rust code tends to be incredibly reliable. If it compiles, it usually works correctly. You spend more time fighting the compiler up front, but far less time debugging in production. TypeScript gives you faster iteration at the cost of more runtime errors. Rust gives you slower iteration but much higher confidence in correctness.
Performance is the elephant in the room. Everyone says Rust is fast, but how much does that actually matter in practice?
For most applications, honestly, it doesn't matter as much as people think. A TypeScript API running on Node, JS, or Bun can handle thousands of requests per second. For a typical web service, the bottleneck is usually the database or the network, not the language runtime. You could rewrite your API in Rust and save a few milliseconds per request. But if the database query takes 50 milliseconds, shaving 2 milliseconds off the language layer is not worth the engineering effort. Where Rust's performance absolutely matters is in compute-intensive workloads, image and video processing, machine learning inference, compression algorithms, cryptographic operations, parsing large datasets. In these scenarios, Rust can be 10 to 50 times faster than JavaScript. That's not an exaggeration. Discord rewrote a single Go service in Rust and dropped tail latency from 300 milliseconds to under 10. Cloudflare's Pingora proxy written in Rust handles more traffic with fewer resources than their previous Nginx setup. These are real production wins that justify the engineering investment.
Let's talk about the job market, because that's what a lot of people care about. Where's the money?
TypeScript has significantly more job openings, by a factor of roughly 10 to 1 compared to Rust. Full-stack TypeScript roles are everywhere. React plus Node or Next. JS is probably the most common job description in web development right now. The average salary for a senior TypeScript developer in the US is around $150,000 to $180,000. Rust jobs are fewer, but they tend to pay more. Senior Rust developers often command $200,000 or more because the supply is so limited. Companies like Amazon, Microsoft, Google, Cloudflare, and dozens of startups are hiring Rust developers and struggling to find them. The Rust Foundation's latest survey showed that 60% of companies using Rust plan to expand their Rust teams. But here's the nuance. If you're optimizing for getting hired quickly, TypeScript is the safer bet. If you're optimizing for long-term career differentiation and higher compensation, Rust gives you a rare and increasingly valuable skill. The ideal position is knowing both, because the developer who can build the front end in TypeScript and write the performance-critical backend service in Rust is extremely valuable.
What about the AI angle? We cover a lot of AI topics on this show. How do TypeScript and Rust fit into the AI ecosystem?
This is where it gets really interesting. TypeScript is becoming the language of AI applications. LangChain has a TypeScript SDK. The Versal AI SDK is TypeScript native. Anthropic's MCP protocol is heavily TypeScript-focused. If you're building AI-powered products, chatbots, RAG pipelines, agent workflows, you're probably orchestrating them in TypeScript. Rust is becoming the language of AI infrastructure. The Hugging Face tokenizer's library is written in Rust. Candle is a Rust-based ML framework. Burn is another. GGML and Llama, CPP have Rust bindings. If you need to run inference at the edge, quantize models, or build custom inference engines, Rust is where the action is. And WebAssembly is the bridge between them. You can write a performance-critical AI inference module in Rust, compile it to WebAssembly, and call it from your TypeScript frontend. That pattern is becoming more and more common. So again, these languages are complementary, not competing. TypeScript is the glue layer for AI applications. Rust is the engine underneath.
I want to push back a bit, though. A lot of the Rust hype feels like it could be a bubble. We've seen languages get hyped before and then plateau. Go was supposed to replace everything. Kotlin was supposed to kill Java. What makes Rust different?
That's a fair challenge. Here's what makes Rust different from previous hype cycles. First, it's not trying to replace a general-purpose language. It's targeting a specific domain, systems programming, where the incumbent options have known fundamental problems. Memory safety bugs in C and C++ are not going away. They're structural issues with the language design. Rust solves them. Second, the adoption is institutional, not just grassroots. The Linux kernel now accepts Rust code. The Windows kernel team is using Rust. Android uses Rust for new components. The White House literally published a report recommending memory-safe languages. This isn't just indie developers on Hacker News. It's the entire industry saying we need to move away from memory-unsafe languages, and Rust is the most mature alternative. Third, Go and Kotlin both had the problem of competing in crowded spaces. Go competed with Python, Java, and Node for backend services. Kotlin competed with Java directly. Rust is competing primarily with C and C++, where the pain is much higher and the alternatives are much fewer. Could Rust plateau? Sure. But even if it does, the floor is very high because the problems it solves are real, expensive, and getting worse.
All right, practical advice time. Someone's listening to this right now trying to decide where to invest their learning time. What do you tell them?
Start with TypeScript if you don't already know it. The return on investment is immediate. You can build full-stack web apps, CLI tools, serverless functions, AI applications. The ecosystem is enormous. The job market is huge. You'll be productive in weeks, not months. We have blog posts 45 and 46 this week covering exactly why TypeScript won and the advanced patterns you should know. Once you're solid with TypeScript, start learning Rust on the side. Don't try to replace TypeScript with it. Instead, think about what problems you encounter that TypeScript can't solve well. Slow data processing, build that module in Rust. Need a CLI tool that starts in milliseconds. Rust. Want to understand how computers actually work at a low level? Rust will teach you more about memory, concurrency, and systems design than any other modern language. Blog posts 47 and 48 this week cover why companies are adopting Rust and how it compares to Go. They're great starting points for understanding the landscape.
So the answer isn't TypeScript or Rust. It's TypeScript and Rust, but in the right order and for the right use cases.
Exactly, and that's increasingly how real companies work. Figma uses TypeScript for their web application and Rust for their rendering engine. Deno is a TypeScript-first runtime written in Rust. TurboPack is a TypeScript bundler written in Rust. SWC is a TypeScript compiler written in Rust. See the pattern? TypeScript for what the user sees, Rust for what makes it fast. If you can work at both levels, you become the kind of engineer who can build entire products from top to bottom. That's a rare and incredibly valuable skill set.
One more thing for the beginners listening. If you're brand new to programming and overwhelmed by all this, what's the single most important takeaway?
Don't worry about picking the perfect language. That's a trap. Pick one and start building things. TypeScript is genuinely the easiest path to building real, useful software right now. You can learn JavaScript fundamentals, add TypeScript on top, and within a few months you'll be building web apps, APIs, and even AI integrations. Rust will be there when you're ready for it. The concepts you learn in TypeScript, functions, types, async programming, data structures all transfer. The important thing is to start. Every week you spend debating which language to learn is a week you could have spent actually learning one.
Let me recap the key points from today. TypeScript is the dominant language for application development and has the biggest job market. Rust is the future of systems programming and pays a premium because talent is scarce. They're complementary, not competing. Most real companies use both. Start with TypeScript for immediate productivity, then add Rust when you need performance or systems-level control. And the developer who can bridge both worlds is incredibly valuable.
Next week, we're going deep on platform engineering and whether it's really killed DevOps or just renamed it. We'll look at internal developer platforms, golden paths, and what this shift means for your career. It's going to be a good one.
If you enjoyed this episode, subscribe wherever you listen to podcasts. Leave a review if you're feeling generous. You can support the show at buymeacoffee.com/amticsoft. And check out the blog at amticsoft.blogspot.com for the full written deep dives on TypeScript and Rust we referenced today. I'm Alex. That was Sam. This has been Bot Thoughts by AmTalk Soft. See you next week.